coming to you from Jezero crater on the surface of Mars. This is Mr. C.
Happy Aloha Friday to you, 8th graders. Hey, you've got that white sheet. If you'll number that to Lucky 13, please. And name, date, period on that upper right-hand corner, huh? So white sheet, number in the 13, listening with both ears, using your eyeballs to number 1 to 13. And you might have a tan sheet too. Hopefully you have a tan sheet as a cover sheet. So a little quiz action in just a little bit. You're numbering to 13. Thank you. And that tan sheet will be a cover sheet as I just said. Okay, hey, don't forget about this little reminder. Let's see, what are we looking at? 3 weeks from today, huh? These are due? Hard to believe. 3 weeks from today, those are due. And on the 19th, which is 3.5 weeks, 3 and a little bit more than a half, probably like 3.8 weeks, on Wednesday, the 19th of May, your journal activities and microscope activities are due. Just reminding you, so you might, at the end of the period, you might have a time just to take a look at your journal and see how many you've got done, whether you're all done, and start to plan a little bit on all of that. Okay, I want to show you, got a couple of things to show you, and want to teach you a few things, and then we'll have our quiz. Okay, I have you're in luck. Aren't you glad you came to science today? Or not, as the case may be. Anyway, you'll really not be glad you came after these groaner teacher jokes. These are teacher jokes, I found them. So I'm going to try to do some teacher jokes for the next few Fridays. Here's one. Anyone know any jokes about sodium? Nah. What's the chemical symbol for sodium? Na. Anyone know any jokes about sodium? Nah. Or Na. All right, here's another one. Why can't you trust an atom? They make up everything. So, oh, that is so bad. Last one for the day. Thankfully, you're going to be saying, what do you do? This applies to me and my dumb science jokes. What do you do when no one laughs at your science jokes? Keep trying until you get a reaction. So, those are bad. So anyway, and there's a whole lot more bad ones where they came from. So anyway, I will get to those in a little bit. Hey, another reminder about the constellations. Don't forget, we're gradually losing Orion high in the west, 8:15 to 8:30 now, and Sirius, the brightest star. So point them both out, the constellation Orion, and then also the belt stars pointing to Sirius. Then right overhead, what do we have? The Big Dipper and its handle stars point to the east to follow the arc to Arcturus, and the cup stars point north to the pole star Polaris above the North Pole. So anyway, and so you get points for that. And if you spot a jacaranda tree, the one with the purple flowers, on a sheet of paper, write down, I saw a jacaranda tree, get a parent signature on that and the constellations, and Bob's your uncle on them. So anyway, reviewing really quick Newton's laws of motion. An object that is not moving like that, an object at rest, not moving, will continue at rest until acted upon by a force, a push or a pull. An object that is moving will keep moving in a straight line unless acted upon by a force. Newton's second law, F equals ma, F for force. So force equals m times a. Mass times acceleration. Mass, how many atoms something is made of. So the more mass, the more force it potentially could have. And a is acceleration, or speeding up, slowing down, don't do it again, or changing direction. When you see the video a little bit later on the Wild Thing roller coaster in Minnesota. It's a favorite of my son-in-law. He recommended it, so you'll see it at the end of the period. I'm going to try to show you from the front seat a roller coaster ride every day. So, and we'll compare them. So anyway, I will get to that in a little bit. I've also got a video. Let's see, I probably should do Newton's third law. So Newton's second law, F equals ma, force equals mass times acceleration. And if mass goes up, then the force goes up. More force, more push or pull. And then if acceleration goes up, the force goes up. And if both go up, you multiply them together, and the force really goes up. Okay, and Newton's universal law of gravitation, what did he say? Every object in the entire universe pulls on every other object. So the gravitational force, this is his universal law of gravitation, every object in the universe pulls on every other object. And it depends how hard they pull on each other. It depends on, one, the mass of the two objects, how much mass they have. More mass, more pull. More mass, more gravity, gravitational attraction. And then the other variable is the distance between the objects. The closer they are, the harder they pull on each other. Now, just rights, the Lord put the moon just the right distance and gave it just the right mass, and gave Earth just the right mass. He did the same thing with the sun. He put it the right distance from the Earth and gave it the right mass, so the gravity would be just right. And he gave us the right bone strength to match the gravitational strength. None of it's an accident. All brings glory to God. Couldn't have just happened. Like evolutionists say. Oh, please. So tired of hearing the silly, willy idea that makes no sense accidentally happening. Just doesn't make any sense. So anyway, that is Newton's universal law of gravitation. Every object in the universe pulls on every other object. And then his other three laws. Okay, so again, the two variables that affect the gravitational pull between two objects, their masses, how many atoms they have, how much matter they're made of, and the distance between the objects. The closer you get, the more gravitational pull, the more mass you get out of each object, the more gravitational pull. Okay, so all of that. And again, mass is the amount of matter that an object has, and then your weight is how hard you're pulled. So my weight on Earth, if I weighed, how should I do this? I'll just say it this way. My weight is about 160 pounds. It's how hard I'm pulled. So that's my weight. My mass is a different story. That's how many atoms my body is made of. So anyway, so that's mass and weight. Okay, I want to show you this. This would be a pretty good action-reaction video. Here it is.
T-minus 10, 9, 8, 7.
Action, reaction.
5, 4,
5 million pounds being thrown into space. Wow. So tremendous action and tremendous reaction. That space shuttle in 10 minutes is going to get going 17,500 miles an hour. Wow. Unbelievable. 10 minutes. That's how powerful those rocket engines are. 3 of them. Throwing 5 million pounds into space and getting it moving 17,500 miles an hour. That's orbital speed. So they can match the speed of the International Space Station. Anyway, I love that video. That is an awesome video. Law of action, reaction right there. So anyway, I wanted to show you this. Do you see the shadow down below? Ingenuity helicopter flying above the surface of Mars, and a little bit more of a shadow there, and pictures that it's taking from above, and then some other pictures too from Perseverance, just right there on the ground. So anyway, I wanted you to see that, and then I want to show you this. I have another cool video that matches. Let's see if I can get it primed. You are going to see a video, has to do with gravity, of Felix Baumgardner. There he is. And he's 120,000 miles. Sorry, Master C, come on. 120,000 feet above the Earth's surface, over New Mexico, I think. So there he is, about ready to jump out of the spacecraft that was helium balloon lifted above the crust of New Mexico. He's just about ready to jump. You're going to watch it. You're going to watch the 4-minute video. And I want to tell you just a few things about him. He wanted to break a record. Back in 1960 maybe, he was a test pilot, really brave guy, and he free fell from space, I want to say like 12 miles up. Okay, Baumgardner is like 24 miles up. So he wants to break the free fall record, and he wants to break the speed of sound. So he's got to get going like 760 miles an hour. So you watch him free fall toward Earth. Yeah, and it's a scary thing. He ends up not falling the way he was trained to. And does he recover or not? So he wants to go 760 miles an hour and some change. And he wants to deploy his parachute in time, but he wants to free fall longer than Joseph Kittinger, who free fell for 4 minutes and change. So will he break those records? Will he break the speed of sound and fall faster than any human? And will he set the record from the highest altitude? So now, if he pulls his chute early, he might not break the record. So you'll have to see whether he does that in a little bit. I better check the time, huh? Because I've got to get that quiz in, don't I? So what do we got on the time? Okay, doing good. Doing really good. Well, I'm trying to throw a lot of stuff out there really quick. And then I want to show you this. You're going to see this video. And I'll show you a minute's worth, but I want to get this going. Here we go. Perfect. And I want to demonstrate acceleration. Do you remember velocity is your speed in a certain direction? Remember, speed is distance divided by time. how far you travel in X amount of time, and you divide by the time, right, for speed. So you remember that velocity is your speed in a given direction. Well, then do you remember acceleration? Acceleration is speeding up, slowing down, or changing direction, like this. Anyway, you're going to see the whole video, but a nice little video demonstrating acceleration. Speeding up, so slowing down, like you do in a roller coaster, and changing direction. So, anywho, so look forward to those two videos, about 5 minutes worth of videos. By the way, I'm going to do my best over the next 3 weeks to get you ready for the semester exam, teach you a few more things in physics, and I'd like to show you, like I say, a coaster video every day, a drop, okay, and other science videos as they match what I'm teaching. Now, let's see if I have this. I think I've got this, yeah. And the fellow who videos these roller coasters, he does this. He checks the data out on each roller coaster, and I thought it's a good scientific method experiment. So the problem is which roller coaster falls or from the highest point, which one goes the fastest. Okay, so anyway, here's my little chart. So we'll start it today with Wild Thing from Minnesota. So, and Wild Thing is going to drop 196 feet, almost 200 feet, and the height is 207 feet, the highest point that it gets, and it gets going 74 miles an hour. So anyway, we'll keep a chart to figure out, and we'll get in at least 10 coasters, 10 roller coasters. Those of you who are roller coaster fanatics, like this guy is. His website is called Coaster Fanatics on YouTube. Coaster Fanatics. So I'm going to use him. All right, you've got your white sheet. Here we go. I'm going to go really quick. So on your quiz, cover it up, sit up straight. Don't look to the left or right. Be honest. Mr. Phillip is encouraging all of that and keeping an eye out for that, or two. So anyway, here we go. Number 1, 2 of the 4 kinds of friction. So number 1 on your quiz sheet. Quickly, 2 of the 4 kinds of friction. Just 2 of the 4. Write fast. Just 2. I will give you half a bonus point if you come up with the other 2. If you can get all 4, write fast. All 4 kinds of friction. Remember, friction is when surfaces touch or rub against each other. The harder they rub, the more, or touch or push on each other, the more friction you've got. So 2 of the 4 kinds of friction, number 1. Number 2, a push or pull. What do we call a push or a pull in science? Number 2, a push or pull. So number 1, 2 of the 4 kinds of friction. Number 2, any push or pull in science is known as what? Number 3, when something is in motion, how can you tell it's in motion? How do you tell if something's moving? I spent some time on this. I showed you the swaying buildings during that big earthquake in Japan. How can you tell any object is in motion or moving? That's number 3. How can you tell? Just a short answer. Number 4, distance divided by time is the formula for what? The mathematical formula for what? It's a one-word answer. Number 4, distance over time. The distance you traveled divided by how long it took you is a scientific formula for what? One word. Number 5, what was Laura's main point in her talk to you last time? Here's what she wanted to teach you, that you can, and you have to finish it. If you put a one-word answer, that won't make it. You won't get anything. Her point was that you can, and you need a bullet fact answer. Number 5, what was Laura's main point? It's a good one. A good one you need to know as a teenager to take you into young adulthood and then adulthood. She was trying to encourage you, you can what? Number 5. Number 6, proteins are made of what building block? There's 20 of them. What are they? The hint I'll give you is double A. 2 words that start with the letter A. Proteins are made of what building block? And I'm not asking this, but because you can reuse them over and over and over and over again, you can get chains that are thousands of double A's long. And they're very complex, and they have to have just the right order. So they absolutely prove God made them. Okay, number 7, the Mars helicopter, what's its number 1 job? No, it's not taking photos of Mars' surface. That isn't its number 1 job. What is it? Number 1 job of ingenuity. Number 8 and number 9. Number 8 is Newton's third law. He says that for every action, finish it. Newton's third law of motion. Isaac Newton's third law of motion. For every action, finish it, please. For every action, number 8, there is what? It's number 8. Boy, it would have helped to pay attention, wouldn't it? Oh yeah. Oh yeah. Number 9, Newton's second law is force equals something times something, half each. The amount of force that you get, how much force, depends on the something of your object and the other something of your object. Not letters, I need words. Use your words. Newton's second law of motion, force equals, or F equals, it's M times A, but you've got to reuse the word, the M word and the A word. That's number 9. Number 10, acceleration. What is it? When you accelerate, it could be one of 3 things. Give me 2 of them. Accelerating is something and something or something. When you accelerate, or when an object accelerates, it does this or that or that. So acceleration gives 2 of the same things that acceleration involves. It's number 10. Number 11, what are gravity's 2 variables? There'll be more gravitational pull between 2 objects if their and increase. What are the 2 variables? There'll be more gravity between 2 objects if these 2 variables increase. Going to give us a hint on these? Nope. And lastly, number 12. The amount of matter that any object has. How many atoms it's made of? What do we call it? One word answer. It's number 12. The amount of matter that an object has is known as its what? So it's out of 12. And here are your answers. So red pen or another pen or pencil. I didn't have enough time for this. If you knew it, you would have had enough time. And good news now, it's an optional quiz. But be honest as you grade it. All right, here we go. Number 1. 2 of the 4 kinds of friction. There's sliding friction, rolling friction, static friction, not moving friction, and fluid friction, moving through air or water. So name 2 of those. If you've got all 4, put plus 1/2. Sliding, rolling, static, and fluid. A push or pull is a force. Number 2 is force. Number 3, how can you tell if something's moving? It moves against the background or a reference point. It moves against a background. Like you can see my hand moving against my face. Moves against the background. Number 4, distance divided by time is a formula for speed. Speed. Number 4, speed. Number 5, Laura's main point. You can do anything you practice. You can do it. You'll do better. Or you can do better at anything you practice. And if you practice a lot, you'll get really good at it. You can do anything you practice. Number 6, proteins are made of amino acids. Number 6, amino acids. Number 7, the major job of the Mars helicopter, don't crash. Not to crash. No other answer. Number 7, don't crash. Number 8, Newton's third law of motion. For every action, there's an equal and opposite reaction. You've got to have all of that. Equal and opposite reaction. If you just have part of it, like equal reaction, that's half. Or opposite reaction, half. Newton's second law, F equals mass times acceleration. M for mass, A for acceleration. Mass times acceleration. Acceleration is either it's speeding up, slowing down, or changing direction. Speed up, slow down, or change direction, like you'll do on the roller coaster. Number 11, gravity's 2 variables, mass and distance between the objects, half each. So mass and distance, half each. On acceleration, each of the 2 is worth half. And finally, number 10, the amount of matter an object has is mass, nothing else. The amount of mass, M-A-S-S, number right, over 12, please. Name, date, period, upper right-hand corner. Pass it into the center. Number right over 12, and pass it into the center. Pass it in if you want a grade on it. If you know it's not going to help you, if you got a 50% or 2/3, that's not going to help you. So if you got an 8 out of 12, if you're 9 and above, it could potentially help you. 11 and 12, I'd turn it in for sure. Okay, you're going to watch the video on Felix Baumgardner falling from space. Does he get going the speed of sound? And then the roller coaster called Wild Thing in Minnesota. So now that'll be Mr. Phillips' discretion, but I think you might be able to squeeze him in. Mr. Phillips.